Hi, and welcome to Dr. V's Chemistry Webcast. In this webcast, we're going to learn how to write names and formulas for binary ionic compounds with type 2 cations. What do we mean by that? What are we trying to do in this webcast? Well, we want to write formulas for binary ionic compounds, so compounds that contain a metal and a nonmetal, where the metal is a transition metal that can form more than one cation with different charges. And we're going to write names for these, and the system we use for naming these compounds is called stock notation. So when we have these type 2 cations, transition metals that can form more than one charge, we have to name them in a certain way. Okay, so in order to do this successfully, we need to know how to name transition metal cations. One of the hallmarks of this category of elements is that they can form several different cations with different charges. For example, the metal iron typically forms one of two ions. It might form the Fe2 plus ion. Here's a compound that contains Fe2 plus ions. Or it might form the Fe3 plus ion. Here's a compound that contains Fe3 plus ions. Notice they have different colors. We often see that with our transition metals. But how do I know which one I'm talking about? If I just say an iron ion, do I mean the 2 plus ion or the 3 plus ion? I need to indicate this clearly in the name. So to name them, what we're going to do is put the charge of the cation as a Roman numeral in parentheses. So Fe2 plus, we would call iron 2. So I wrote a Roman numeral 2, and I say iron 2. Fe3 plus, I'm going to call that iron 3. So I can distinguish between them. Iron 2 for the 2 plus charge, iron 3 for the 3 plus charge. So it's expected you'll know that you've got a transition metal that can form more than one cation, and that you're going to put the correct Roman numeral in. It's got to be the correct Roman numeral. There's no wiggle room here. If it's Fe2 plus, it's got to be iron 2. Whatever element it is, you have to put in that right charge. Okay, but wait a minute. We've written other formulas where there wasn't a Roman numeral. Right, because we only use the Roman numerals for these type 2 cations that can form more than one charge. For our group 1 metals that only form plus 1 ions. For our group 2 metals that only form plus 2 ions. I don't need a Roman numeral. We know what they do, and so the Roman numeral is unnecessary. Similarly, we talked the other day that silver only forms a plus 1 ion, zinc only forms a plus 2 ion, aluminum only forms a plus 3 ion. So these are all examples of what we can call a type 1 cation. They only form one charge, and I don't need a Roman numeral with these. So we don't use them. We only use them when we have to with our transition metals. Now, when you're doing formula writing where your cation is a mercury ion, you have to be very, very careful. It's very easy to make a mistake with these. So if we look at Hg2+, notice that it's a monatomic ion with a charge of plus 2. And then there's also a polyatomic ion, Hg2, 2+. So we have our monatomic ion, Hg2+, which we call mercury 2 for the monatomic ion. And then the polyatomic ion, there are two atoms of mercury combined together, sharing a plus 2 charge, and we call this mercury 1. So you do need to be really, really careful. Mercury 2 is monatomic, mercury 1 is the polyatomic ion. Don't get them confused. So easy to do that. Okay, so let's do a little practice naming some monatomic type 2 cations. Cr3+, it's a chromium ion. The charge is plus 3. We're going to call it chromium 3. Pb2+, that's a lead ion. It's got a charge of plus 2. It's the lead 2 ion. Sn4+ is the tin 4 ion. So even though lead and tin are in the P block, they're in the main block, they actually behave as transition metals and form more than one charge, so they're type 2 cations. And V5+, that would be vanadium 5. So we can have all different kinds of ions here. Okay, let's do some practice where I give you the name of the ion and let's write the correct symbol. Lead 4 would be Pb4+. Gold 1 is Au+. Tungsten 6, W6+. Platinum 2, Pt2+. So the Roman numeral tells us the charge of the cation. That's a really important thing to remember. It's something that sometimes students forget. I don't want you to forget it. All right, so now that we know how to name type 2 cations, what does that do in terms of formula writing? Well, really, not that much. We still write the cation first and then the anion. Write the cation symbol with its charge next to the anion symbol with its charge. And then we need to look at the ions to decide what the subscript should be. We need electrically neutral compounds. So the sum of the positive charges has to equal the sum of the negative charges so that the overall charge is 0. So we put in subscripts to make that happen. The lowest common multiple can be really helpful here. I want to remind you, we don't show any charges in the final written formula, just the numbers and types of each atom. And we don't put Roman numerals in formulas either. Sometimes I see students do that, and that's an absolute no-no. It's just not done. All right, so what about naming compounds? First, we give the cation name, then we give the anion name. That really hasn't changed at all from what we've done earlier in this unit. We do need to remember that if the metal can form more than one cation, I need to give a Roman numeral for the charge of that metal in the name. And if it's expected to be there, it needs to be there, and it needs to be the right number. All right, let's work through an example together. What's the correct name and formula of the compound known colloquially as rust, formed from the iron 3 ion reacting with oxygen? So we know it's iron 3, Fe3+, we're told that. And we know oxygen is a group 16 element, so when it forms an anion, its charge will be -2. We write them side by side. All right, so if I'm looking at one iron 3+ ion and one oxide ion, will the sum of the charges be 0? No, that doesn't work out to 0. So let's think about how many copies we need of each to make this work. If I have 2 copies of iron 3+, that gives me a total positive charge of 6. If I have 3 copies of the oxide ion, that gives me a total negative charge of 6. That lowest common multiple of 3 and 2 is 6, right? And so 2 Fe3+ ions and 3 oxide ions gives me a neutral compound overall with a net charge of 0. So my correct formula is Fe2O3. And now I know that it's iron 3, right? That's the name of the Fe3+ ion, and the oxide ion is the anion, so it's the cation name and the anion name, and therefore it's iron 3 oxide. Let's do some more practice. You can't be too good at this. Now, I'm not necessarily going to show all the numbers of ions, but we'll write correct formulas and talk through the process. If I have SN4+ reacting with sulfur to make an ionic compound. Now I know that sulfur is a group 16 element, just like oxygen, so when it forms an ion, its charge will be -2. So let's write these two ions side by side, SN4+ and S2-. 1-to-1 ratio, that's not going to give me a sum of 0 for the charges. So if I had 2 copies of sulfide, though, that would work. And so the formula is SNS2, and the name would be tin 4 sulfide. So common mistake, students will see the ion charge and want to write it as the subscript for that same element. Nope, you can't do that, right? The Roman numeral for the 4 is telling me the charge of the tin ion, right? And the sulfide ion is the name of the anion. So it's tin 4 sulfide, and the formula is SNS2. Let's do another example. Cu2+ reacting with nitrogen. Group 15 for nitrogen, it's going to form an anion with a charge of -3. So I've got my copper ion, Cu2+. I've got my nitride ion, 1-to-1 ratio. That's not going to give me a sum of 0 either. So we can think about lowest common multiples, right? It would be 6. So if I had 3 copies of Cu2+ and 2 copies of N3-, that would work and give me a neutral compound. So my formula is Cu3N2. And then for the name of it, remember, it's the cation name and the anion name. Copper is a transition metal. It can form more than one cation. In this case, we're told it's +2. And so it's copper 2 nitride. So remember, the Roman numeral tells me the charge of the ion, not how many copies I have of it. That we have to work out from the lowest common multiples. Sometimes students find naming compounds with transition metals to be a little bit tricky. So we're going to do some extra practice problems with this. FeCl3, here's the formula. I'm telling you that's the formula. So let's break it down. What this formula is telling me is that I have 3 copies of the chloride ion, right? I have 3 times Cl-. Remember, Cl- is a monatomic ion. So we need to figure out the charge of the iron ion. We need a neutral compound. So I like to do an algebraic approach here. The charge of the iron ion is X. I've got 3 copies of -1. The sum of this has to be 0. What does X need to be? Well, the iron ion must have a charge of +3 in order to make this a neutral compound, and therefore its name is iron 3 chloride. Let's do another example. Cu2Se. So I see here that I've got 2 copper ions. I've got 1 selenium selenide ion, all right? And I know that the selenide ion in group 16 has a -2 charge. Okay. And I have 2 copper ions, and the sum of all the charges in the compound have to be 0. So what does the charge have to be on those 2 copper ions? I have 2 of them, and then it must be a cation, and then I have -2 for the selenide ion, and they have to add up to 0. So the copper ions must each have a charge of +1. And therefore, the name of this compound would be copper 1 selenide. Okay. Listen, you really just need to keep practicing these skills until you've got it. Lots and lots of practice problems. If you're having trouble, go talk with your teacher. Go get extra help. That's how you learn. That's how you get better. But let's just summarize the rules that we've been talking about. For metals that form more than one cation, you use a Roman numeral to indicate the cation charge in the name of that cation. Formulas have to be neutral, so we're going to select the subscripts so that the sum of the charges will be 0. And this is where lowest common multiples can be very handy. We name ionic compounds by giving the cation name and then giving the anion name. And we have to put those Roman numerals in for metals with variable cation charges. So those transition metals that can form more than one cation, if I expect a Roman numeral to be there, it's got to be the right Roman numeral, the one that fits that formula. And that's the way it's got to be, folks. So if you found this webcast to be helpful, make sure you subscribe to my channel and leave a comment, and we'll just keep learning more chemistry every day.